The National Electrical Code, NEC, Article 360 addresses wiring methods and materials. Section 360.11 specifically covers raceway or cable tray installation. Subsection A, metallic raceway secured, states that conduit and raceway shall be securely fastened in place. Subsection B, non-metallic raceway secured, requires that non-metallic raceways be securely attached to the building structure. Section 360.22 focuses on flexible cord and cable protection, mandating that flexible cords and cables shall be protected from damage. Furthermore, Section 360.54 addresses conduit, tubing, and cable tray supporting, stating that where supported by other than the building structure, conduit, tubing, and cable tray shall have a support at intervals not exceeding 5 feet 6 inches, or 1676 millimeters. Based on these NEC requirements, all wiring methods, including raceways, cables, and conduits, must be securely fastened to the building structure. This ensures proper support and protection from damage for the wiring system. Regarding modular wiring systems installed directly on the slab without strapping, it's essential to evaluate compliance with these NEC requirements. The code requires conduits to be securely fastened to the building structure. Installing the system directly on the slab without strapping may not meet this requirement. An inspector might require strapping the modular wiring system to the slab out of concern that it's not adequately supported or protected from damage. When discussing this with the inspector, you should provide information about the system, including documentation from underwriters' laboratories, all demonstrating its approval for use without strapping. If the inspector remains unconvinced, additional support for the system may be needed, such as strapping the conduits to the slab or installing a cable tray securely fastened to the building structure. Remember that local interpretations and enforcement can vary, even with a nationally recognized code like the NEC. Providing comprehensive documentation and engaging in open communication with the authority having jurisdiction, OJ, is key to resolving any discrepancies. The NEC general requirements for wiring methods dictate that all installations must be performed in a neat and workmanlike manner. This means that cables and raceways must be installed so that they are not subject to physical damage. It also means that all supports must be adequate to carry the weight of the cables and raceways. The NEC requirements for wiring methods are designed to ensure the safety of electrical installations. By following these requirements, installers can help to prevent fires, shocks, and other electrical hazards. When installing electrical systems, there are several key considerations to keep in mind to ensure compliance with the NEC and maintain a safe and reliable installation. Firstly, proper grounding is crucial. Grounding provides a path for fault current to return to the source, which helps to protect people from electric shock and reduces the risk of fire. The NEC specifies the requirements for grounding systems, including the size and type of grounding conductors, the methods of grounding electrodes, and the bonding of metal parts. Secondly, overcurrent protection is essential. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. The NEC specifies the requirements for overcurrent protection, including the size and type of overcurrent protection devices, the location of overcurrent protection devices, and the coordination of overcurrent protection devices. Thirdly, proper wiring methods are necessary. The NEC specifies the requirements for wiring methods, including the type of wiring permitted for different applications, the size and type of conductors, the methods of installing conductors, and the protection of conductors from physical damage. It's important to use the correct wiring methods for the specific application to ensure a safe and reliable installation. Fourthly, compliance with the NEC requirements for boxes and enclosures is important. The NEC specifies the requirements for boxes and enclosures, including the type of boxes and enclosures permitted for different applications, the size of boxes and enclosures, and the methods of installing boxes and enclosures. The correct type of boxes and enclosures must be used for the specific application to protect electrical connections and equipment. Fifthly, clearances and working space around electrical equipment must be maintained. The NEC specifies the requirements for clearances and working space around electrical equipment, including the minimum clearances required for different types of equipment and the requirements for access to electrical equipment. Maintaining adequate clearances and working space ensures that electricians can safely install, maintain, and repair electrical equipment. Sixthly, proper labeling and identification of electrical equipment and circuits are necessary. The NEC specifies the requirements for labeling and identification of electrical equipment and circuits, including the type of labels required, the information that must be included on labels, and the location of labels. Proper labeling and identification help to prevent confusion and ensure that electricians can quickly and easily identify the correct circuits and equipment. Seventhly, adherence to the NEC requirements for special occupancies is essential. The NEC includes special requirements for certain occupancies, such as healthcare facilities, hazardous locations, and places of assembly. These special requirements are designed to address the unique electrical hazards that are present in these occupancies. Compliance with these special requirements is crucial for ensuring the safety of people and property. Eighthly, regular inspection and testing of electrical systems are necessary. Regular inspection and testing can help to identify potential problems before they become serious hazards. The NEC recommends that electrical systems be inspected and tested regularly by qualified electricians. Ninthly, it's important to stay up to date with the latest edition of the NEC. The NEC is revised every 3 years, and it's important to be aware of the latest changes to the code. Staying up to date with the latest edition of the NEC helps to ensure that electrical installations are safe and compliant. Tenthly, working with qualified electricians is crucial. Qualified electricians have the knowledge, skills, and experience to safely and properly install, maintain, and repair electrical systems. Working with qualified electricians helps to ensure that electrical installations are compliant with the NEC and that they are safe and reliable. The NEC provides specific guidelines for various aspects of electrical installations in different environments. For example, in damp or wet locations, the NEC requires the use of wiring methods and equipment that are specifically listed for those locations. This includes using conductors with moisture-resistant insulation, installing weatherproof enclosures, and providing proper drainage to prevent water from accumulating around electrical equipment. In hazardous locations, such as areas where flammable liquids or gases are present, the NEC has stringent requirements for the type of electrical equipment that can be used. This equipment must be designed and approved for use in hazardous locations to prevent explosions or fires. NEC also specifies the requirements for grounding and bonding in hazardous locations to minimize the risk of static electricity buildup, which can also ignite flammable materials. For healthcare facilities, the NEC includes special requirements to ensure the safety of patients and staff. These requirements include the installation of isolated power systems in critical care areas to prevent electrical shock hazards. The NEC also specifies the requirements for emergency power systems to ensure that critical equipment, such as life support systems, can continue to operate during a power outage. In agricultural buildings, the NEC addresses the unique electrical hazards associated with these environments, such as the presence of dust, corrosive materials, and livestock. The NEC requires the use of wiring methods and equipment that are suitable for these conditions, such as dust-tight enclosures and corrosion-resistant materials. The NEC also specifies the requirements for grounding and bonding in agricultural buildings to prevent stray voltage, which can harm livestock. When installing electrical systems in commercial buildings, the NEC has specific requirements for the type of wiring methods that can be used, the spacing of receptacles, and the installation of lighting. The NEC also requires that commercial buildings have adequate electrical capacity to meet the needs of the occupants. For residential buildings, the NEC provides guidelines for the installation of wiring, receptacles, lighting, and appliances. The NEC also specifies the requirements for ground fault circuit interrupters, GFCIs, to protect against electrical shock hazards in areas such as bathrooms, kitchens, and outdoor locations. Understanding the specific requirements of the NEC for different types of occupancies is essential for ensuring the safety and reliability of electrical installations. It is important to consult the latest edition of the NEC and to work with qualified electricians to ensure that all electrical work is performed in accordance with the code. In addition to the specific requirements for different types of occupancies, the NEC also includes general requirements that apply to all electrical installations. These general requirements cover topics such as grounding, overcurrent protection, wiring methods, boxes and enclosures, clearances and working space, and labeling and identification. Compliance with these general requirements is essential for ensuring the safety of all electrical installations, regardless of the type of occupancy. The NEC also includes requirements for the maintenance of electrical systems. These requirements include regular inspection and testing to identify potential problems before they become serious hazards. The NEC also recommends that electrical systems be inspected and tested regularly by qualified electricians. Proper maintenance is essential for ensuring the continued safety and reliability of electrical systems. The NEC is a complex and comprehensive document, and it can be challenging to understand all of its requirements. However, it is essential to have a thorough understanding of the NEC to ensure that electrical installations are safe and compliant. Consulting with qualified electricians and attending training courses can help to improve understanding of the NEC and to ensure that electrical work is performed in accordance with the code. The NEC is not a static document, and it is revised every 3 years to keep pace with changes in technology and industry practices. Staying up to date with the latest edition of the NEC is essential for ensuring that electrical installations are safe and compliant. The NEC is an essential tool for ensuring the safety of electrical installations. By following the requirements of the NEC, electricians can help to prevent fires, shocks, and other electrical hazards. The NEC also helps to ensure that electrical systems are reliable and that they will provide safe and dependable power for years to come. The NEC requirements for flexible wiring systems are detailed and specific, aiming to ensure safety and reliability. Firstly, the type of flexible wiring system used must be appropriate for the application and environment. The NEC classifies flexible wiring systems into various types, such as flexible metal conduit (FMC), liquid-tight flexible metal conduit (LFMC), and flexible non-metallic conduit (FNMC), each with its own set of approved uses and limitations. Secondly, the size of the flexible conduit or cable must be correctly selected based on the number and size of the conductors it will contain. The NEC provides tables and guidelines for determining the appropriate size of flexible conduit or cable to prevent overheating and ensure proper ampacity. Thirdly, the flexible wiring system must be properly supported and secured to prevent physical damage and strain on the conductors. The NEC specifies the maximum distances between supports for different types of flexible conduit and cable. Fourthly, fittings and connectors used with flexible wiring systems must be listed and labeled for the specific type of conduit or cable being used. These fittings and connectors must also be properly installed to ensure a secure and watertight connection. Fifthly, flexible wiring systems must be properly grounded and bonded to provide a safe path for fault current. The NEC specifies the requirements for grounding and bonding flexible wiring systems, including the size and type of grounding conductors and the methods of connecting to the grounding electrode system. Sixthly, flexible wiring systems must be protected from physical damage. The NEC requires that flexible wiring systems be installed in locations where they are not subject to physical damage, or that they be protected by a suitable barrier. Seventhly, flexible wiring systems must not be used in hazardous locations unless they are specifically listed and labeled for such use. Hazardous locations require specialized wiring methods and equipment to prevent explosions and fires. Eighthly, flexible wiring systems must not be used in lengths longer than specified by the NEC. Excessive lengths of flexible conduit or cable can increase the impedance of the circuit and reduce its efficiency. Ninthly, flexible wiring systems must not be installed in areas where they are exposed to excessive heat, oil, or other corrosive substances. These substances can damage the insulation of the conductors and cause a short circuit or other electrical hazard. Tenthly, flexible wiring systems must be inspected and tested regularly to ensure that they are in good condition and that they are functioning properly. Regular inspection and testing can help to identify potential problems before they become serious hazards. The National Electrical Manufacturers Association (NEMA) also provides guidance and standards for flexible wiring systems. NEMA standards cover topics such as the construction, performance, and testing of flexible conduit and cable. Consulting NEMA standards can help to ensure that flexible wiring systems are installed in accordance with best practices.